Reminder that if on Monday the polynomials are not handed in, you get a 0 because I'm marking it and handing it back the next day. So if I just take off part marks, that's silly because the answers will be up. Silliness. So leave yourself a little reminder in your phone if you're someone who does not have yours done. Okay. Reflections are a mirror image about a line or an axis. We're not doing lines in 30-1. It used to be in the old curriculum, which is really old because it was in 2011 was the last time the old curriculum was done. So invariant points are points that do not move after a transformation. So we're going to do reflections in the x-axis where graphs are up here and down here, or they're down here and now they're up here. Or reflections in the y-axis where they're over here and now they're over here, or they're over here and now over here. Do you reflect about the y-axis, or we're going to reflect about the x-axis? Before we even go do any of this, if I am a point, hello, here I am. Nope, no I'm not. Okay, let's try again. I am a point, here I am. If I am here, here is me. I'm a point. I actually make up a smile. Okay. I have one really large eye. I'm cute. Look at me. Okay. So if I reflect in the x-axis, where am I going to end up? You know it's Friday when you all straight-faced me and I drew that and nothing. Amy smiled. That's all I got. I think Riley did. Oh, thank you, Julie. Julie. I have to add an to the end of it.
I think quadrant 1.
Yes. Quadrant 1. Very good. What? Why? I don't even know what I said, but I'm going to go with why because then his answer is correct. Okay, so it would be here. Oh, I'm too, okay. Let's pretend those are symmetrical. They're not. Okay, so if I reflect in the y, and I'm the black smiley face to the red smiley face, what changed in coordinates? Your x values, what happened to them? They went positive. Boom, shakalaka. Exactly. So, if you have xy, it's going to become negative xy because all your x's are going to be negated. So these negative ones are now going to become positive. If it was the red one first, the positives are going to become negative when I reflect on the y-axis, correct? So this is when you reflect. You might want to write this down. Reflect about or in reflection. What? Because it's blinking, causing me problems with your start computer, and I found that out at 8:45-ish. So it does suck, and that's a smart word that sucks, not me. Clarification. Okay, reflection in the y-axis. Now, what if I'm the black smiley face and I'm reflected in the x-axis? What's going to happen? It's going to go from quadrant 2 to quadrant 3. Let's see if I can replicate it a little better this time. Nope, not much better. Okay, so if my y values were positive, they're now all negative. Did my x's change at all? No. So if I have xy becomes x negative y, it means all my positive y's will become negative. So what axis am I flipping in? X. The x. And if they're going negative this way, I'm flipping in the y. So this is a reflection in the x-axis. And invariant points are points that do not move after a transformation. That's something we can keep in mind for a little bit here. Okay. We're going to graph the graph of y equals x squared minus 4x plus 4. Please type it into your calculator. X squared minus 4x plus 4. I'm not going to type it into mine because we don't have a ton of time. You type it into yours. We're going to have a concave up parabola. So a parabola that's opening up. Why is it a parabola that's opening up, and why do I know that already? Yeah.
Smiley face, that's what would be upside down.
Oh, yeah. I just transferred it down, hey, instead of reflecting it. Come on, Lepp, you suck. Okay, I can say it's about myself. I was just so into drawing the eyes correctly that I didn't draw the whole thing
Now
correctly.
you get an extra chance.
Oh, it's so high. This is like, oh. Oh, it's getting worse. It got larger. It didn't stretch, just I stopped it strong. Okay, good. This here, I just can't. This here, x squared minus 4x plus 4. How do we know this is concave up? Positive leading coefficient, so it's up on the right. And because it's degree 2, it's also up on the left because of even degrees. So when we type it in, we need to get our minimum. So we're all going to use our calculators. We're going to go second trace minimum to practice. Second trace minimum. Then we're going to go left bound, enter. Then we're going to go right bound, enter, enter. And my minimum's at 2, 0.
It's not less than.
Did I type it in wrong? X squared minus 4x plus 4. No, my minimum is right. It's 0. You have in your calculator, keep in mind when you find your minimum, it's going to be 0 and 2. But some of your zeros might be like 1.3 e to the negative 74 or something like that. If it's e to the anything, that just means you have 0 decimal 0.00001, which we round to 0. So whenever you have an e to the negative anything, that's just 0. Okay? So don't fall to that. And how you'll know, some people will write 13 and 2. And I'm like, but if you look, that's blatantly not 13 and 2. Right? So when you have e to the negative anything, that's just 0. Okay? So we're at 0, 2. Then we're going to go second table or second trace, which is what I'm going to do. Second trace value. And then I'm going to go second trace value, and I'm going to plug in negative 1. Because I want the y that goes with it. It's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Should I draw off? No. I'm going to go y scale of 2. And then I'm going to go x scale of 1. Negative 1, 9. You're, I don't know. 1, 2, 3, 4, 5, 6, 7. I get what you're saying. 2, 4, 6, 8, 9. Then I want to do 0. Second trace value 0. 0 and 4. Don't forget your y scales too. Second trace value 1. 1 and 1. Don't forget your y scales too. I'm actually saying that because I forget the y scales too. Remind me. Then I want to do some on the other side. So I go second trace value 3. 3 and 1. Then I can, oh my gosh, start drawing. It's symmetrical, right? Oh, why is it? Draw. Now, parabolas are not like valleys that are pointed or mountains that are pointed. Parabolas are rounded, correct? So if you just go and sketch it the way it is right now, people will give me this pointed thing. If I want to make it more accurate, I could go second trace 1.5. Second trace value 1.5. And I get 0.25, so it makes me round a little bit more. Oh my gosh, if it lets me draw. So it's going to curve down here. I can get as many points as I want, right? Because I can put in any x value and get out a y. Even decimal. So it's going to be rounded and then up. This is never going to be straight because this is botched part of my board. It makes everything curve. So I label it as y equals f of x. Now it says write the equation y equals negative f of x. What that means is I can go y equals negative, and then in for f of x I can put in this because that's f of x, correct? So I'm going to go y equals negative, and then I'm going to put in f of x. x squared minus 4x plus 4. So y equals negative x squared plus 4x minus 4. Now type that in. We know this one's going to be concave down, correct? Negative leading coefficient. So down on the right, degree 2, down on the left. So type this one in. Now we're going to find max or min. Max. When you find your maximum, it's actually on the exact same point, isn't it? Did that point move? No, we'll explain why it didn't in a second. Now, when I type in second trace negative 1, or second trace, yeah, we'll start negative 1, I'm going to get negative 1 and negative 9 this time. When I plug in 0 instead of 0, 4, I'm going to get 0 and negative 4. And 1 and 1, I'm going to get 1 and negative 1. 3 and 1, I get 3 and negative 1. 4. 9. What did that graph do? It reflected in the x-axis. So we have y equals f of x becomes y equals negative f of x. Remember, this is something to note. When it's in this bracket, it affects x's. When it's here or here, it affects y's. So the negative is in front, so my y's are all going to be negated. So my mapping for this would be x, y becomes what? Is anything happening to my x? My x in my bracket is still just an x, so my mapping will stay in x, right? And so it's going to be x comma what, Helen? Negative y. And you said it's a reflection in the x-axis. And why is it a reflection in the x-axis? Because when your y's negate, the positives become negatives, and the negatives become positive, and what axis am I flipping around here? My x, right? I'm doing this, not this. Why did this remain invariant? Why did this stay the same? It's the only point that stayed the same. Why did it stay the same? Yeah. It's on the x-axis, and when you're on the x-axis, your y is 0. And when you multiply 0 by negative 1, what happens? It stays 0. So when you reflect in the x-axis, this is your mirror. Anything on it will remain the same. So 2, 0 becomes 2 and negative 0, which is 2, 0. It didn't change, right? So when you reflect on the x-axis, your invariant points are on the x-axis if all you do is reflect on the x and not a whole bunch of other things. And why do they remain invariant? Because your y's are 0. When you multiply by negative 0, it stays the same. Any y's above will become negative. Any y's below will become positive. So those aren't going to stay the same, right? But on that x-axis, they'll stay the same. So state the coordinates of the invariant point. It's 2, 0. And how does this graph compare to the other one? It's a reflection in the x-axis. Okay, I want you to sketch the new one of this. So, this says y equals f of x. I want y equals negative f of x. When that negative's in front, what is it? It's a reflection in the x-axis, because when it's with the y, it's in the x-axis. And I'm moving a graph, and a graph has a whole bunch of points. When I move points, what do I use? Mapping. So xy is going to become x, because x stayed the same. There's nothing with the x comma, negative y. So you fill in, I would fill in some arm points. So I fill in this one, and this one. Fill those three in to there and get your new graph. Try it out. So we have 1, 2, 3, negative 4, 0. It's going to become negative 4, negative 0, which is negative 4, 0. Wait, it stayed the same. Why did it stay the same? Because it's actually reflecting on the axis of which we're reflecting on, correct? So this one's also going to stay the same. So the one that's going to move is every other point will move. So we have negative 1 and 4 is going to become negative 1 and negative 4. I think calculators are hardy. Okay. And other stuff is hardy. Okay, we're going to flip over then. So what's the difference in this one? The negatives with the, what this time? Yeah, it's with the x. So before the negative was with the y, correct? So now if the negative is with my x, what's actually going to happen is I'm going to get xy becomes negative xy. So let's just try and figure out where we're reflecting that. So if I have a point here, and it's at negative 3 and 4, let's say, and I'm making my x's be negative and my y's stay the same, it's going to now become positive 3 and 4, correct? So what axis did I reflect on? The y, yeah. I was here, I'm now here. If I'm here, I'm now going to be here. So I'm reflecting on the y, correct? Because my x's are staying the same. I mean, my y's are staying the same, my x's are negated. So it's the reflection in the y-axis. So it's always in the opposite axis than what it's affecting. So if my x's are being negated, that means they're here, then they're here, they're here, then they're here. So it's reflecting in the y-axis, always the opposite axis. And when my y's are being negated, what's up here is going to be down here, what's down here is going to be up here, so it's a reflection in the x. So it's always in the opposite axis of what variable it's affecting. So if it's affecting the x variable, it's negating the x's, then it's a reflection in the y. If it's negating the y's, it's a reflection in the x, because they're going to go like this. Okay? So the last one had a negative in front. This one has a negative x in the bracket. When we have something in the bracket, what does that tell us to do? Say I give you this. F of 2 in grade 10. What did that mean? It's function notation. What did the F of 2 mean? Take the 2 and put it in for all the, what? X is an F, correct? That's what that means. So if I give you F of 2, you'd go 2 squared minus 4 times 2 plus 4. All the 2's would go in for all the X's. We agree? But that's grade 10. That's not what we're doing right now. We're doing F of negative X. So I'm going to put negative X in for all my X's. So here's an X, and here's an X, and instead of putting an X in for them, I'm going to put in a negative X. So I'm going to get Y equals, instead of X squared, I'm going to get negative X squared minus 4, and instead of X, I'm going to have negative X plus 4. So I'm putting negative X in for all my X's. Now if I take negative X and I square it, what do I get?
Negative x squared.
Nope.
X squared.
X squared. Because it's negative 1 squared, which is positive 1, and then X. So it's X squared. And then minus 4 times minus X is positive 4X plus 4. So we have the first graph, X squared minus 4X plus 4. We're going to graph the original. We've done it already. It was at 0, 2, 1, 1. I'm going to make my Y scale. B2. So we've graphed the original f of x already, so I'm going to just do it again. 2, 3, 4. So that's my y equals f of x, correct? Now type my, well, let's just draw it as we actually can. We know it's a reflection in the y-axis, we agree? So we're reflecting it here. So this is at negative 1 and 9. What's it going to now be at? We're reflecting it on the y. Negative 1 and 9 becomes positive 1 and 9. What about this one that's right on the reflection? Stays there, it's the invariant point. And then what about 1, 1? It's going to become negative 1, 1. 2, 0 is going to become negative 2, 0. 3, 1 is going to become negative 3, 1. All my x's are being negated. 4, 2 is going to become negative 4, 2. And then 5, 9 is going to become negative 5 and 9. And if you type this into your calculator, you get this. So this blue graph is y equals f of negative x. Does it look like it's mirroring on that y-axis? Yes. What's the invariant point on this one? Yep. 0 and 4. Why? Yeah. And we are doing xy becomes negative xy, right? That's what we've done. Well, when I plug 0 in to either of these, is it going to change? No. It's because the x's are 0 now. So when it reflects on the y-axis, wherever x is 0 is where you're going to get invariant points. Then how does the graph of y equals f of negative x? So this means all my x's are being negated. So I know it's xy becomes negative xy. But what did I tell you that's a reflection in, though? If it's affecting the x's, it's a reflection in the y-axis. Because if your x's are being negated from here to here, or here to here, you're reflecting on the y-axis, right? So it's a reflection in the y-axis. So when it affects the x's, it's a reflection in the y, and when it affects the y's, it's a reflection in the x. So this is a negative x. So that means I have xy becomes negative xy, and it should reflect on this axis, the y-axis. I want you to draw the new graph. For this one, I know this is going to remain invariant, so I'm just going to put a blue dot there, because it's not changing. This one here, which is at negative 4, 0, is going to be at 4, 0. This one that's at 1, negative 1 and 4 is going to be at 1 and 4. And this one that's at 1, 0 is going to be at negative 1, 0. So look like that. Now we're going to flip over. Remember, it should look like it's reflecting in the y-axis. If it's not, you did something wrong. Oh, good. I didn't print the right. So you should be here. Okay, this one here, I want you to sketch the following reflections on this same grid. So is this with the x? It is not with the x. It's not with the x variable, so it's going to affect what in mapping? The y. So my mapping, and why am I using mapping? Because that's what we do. True. And why do we do it? Because we're moving what? Coordinates. We're not moving one, we're moving numerous. So we really want to. So for this one, our mapping is going to be xy becomes x what? Negative y, because this is a reflection in the x-axis when it affects the y's. Then for this one, it's with my x. So it's going to affect my x. It'll be a reflection in the y. You're right. So this is going to be xy becomes negative x comma y. Do you see if you don't practice these enough and you don't solidify it, you could be like, it affects x, or maybe it affects y. I don't know if it's a reflection in the x or a reflection in the y. That goes really poorly if you don't know them backwards and forwards when it comes to test. So because it affects my x's and my x's get negated, it's a reflection in the y. So I want you to do both of these. I'm doing them in separate colors. I'll do them after you try. You try. So this one I should, because it's a negative y, this, I hope my graph is going to reflect on here, because it needs to, because it's a negative y, which means it's a reflection in the x. So let's try it out. So we're going to have 1, 2, 3, 4, 5, 6. Negative 6, 0 is going to become negative 6, negative 0. Wait a second, it stayed. Why did it stay? Yes, because the y's values are 0. So that one's going to stay, this one is going to stay, and this one is going to stay. Now let's look at the others. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So negative 4, 6 is going to become negative 4, negative 6. Connect. This one's at negative 1, 6. It's going to be at negative 1, negative 6. I'm just plugging it in. I've done this is at 1, 2, 3, 4, and negative 3. It's now going to be at 4 and positive 3. There, up to there, and then that one's the same. So that's the purple one. Does it look like it's reflected on the x-axis? Yes, it should, because it is. If it doesn't, you got problems. Okay? Let's go to green. Green's affecting the x's, so I hope that I have a reflection on the y-axis. You don't actually have to draw this dashed line that I did not draw straight. That's just for you for visualization. You don't have to have the dashed one. So I have negative 6, 0 is going to become positive 6, 0. So it doesn't remain invariant anymore. 1, 2, 3, 4, 5, 6, 0. Then negative 4, 6 is going to become negative 4, negative 6. And by that is not true. Positive 4 and 6. Oh, the eraser's not going to work. My x's are being negated, not my y's. I need to grab a mitt. 4, 6. And then negative 1, 6 is going to become 1, 6. Then this is going to stay the same because it's on the y-axis. And then 4 and negative 3 is going to become negative 4 and negative 3. Then 1, 2, 3, 4, 5, 6, 7, 0. So we can negative 7, 0. Okay. This one here says the thick line is a reflection of the thin. So the thin's the original, the thick is the transformed. What's happening here? Reflection on the x, because where's the invariant point at? The x. And this is going here, and this arm's going here. So this is a reflection in the x-axis. So if we have y equals f of x, what's it being transformed to? Y equals if it's a reflection in the x-axis, what's it affecting? It's negative f of x. If it's a reflection in the x-axis, it has to be with the y. If it's a reflection in the y-axis, it's going to have to be with the x. They're always in the opposite. This one's a reflection in the y-axis, which means my x here is going to go here, and my x here is going to go here. So my x's are being negated, correct? So it's a reflection in the y-axis. So I'm going to get y equals f of x becomes y equals f of negative x, because my x are being negated in order for it to be a reflection in the y. You write the new equations out on here. Example 7. If this is a reflection in the y-axis, what variable is it affecting? The x or the y? X. If it's a reflection in the y-axis, it's affecting the x's, correct? They're moving over here. So my new equation would be y equals 10 to the negative x. The negative sign goes with the x. If it's a reflection in the x-axis, it's with the y. So it wouldn't go in underneath this radical, would it? So it's going to be negative root x. This is half, they teach us in one lesson in the textbook, but we do it in 2. So this is half of 1.2. So it's page 28. Number 3, 4. I just want you to do A for 3. I'm going to rewrite that. That looks stupid. Three A, 4B, 5CD, 7BD, and that's all you can do for now.